Hello, everyone. Alright, so today we are changing up the structure of the midweek stream. I will still be having the stock market update in this video, but at the same time, I wanted to push that further back in the video so that I can get straight to the talk about the AI in general. So I just realized that I need to switch out my mouse for my drawing pad, so bear with the computer noise. All right. So we are going to be talking about my game Sell Me Something, but something specific with the game. So I want to show you something that I have changed in the recent update. Actually, not the most recent update, because I did post an update just an hour ago, I believe. That was just somewhat of a visual update. I added a button on the controls page in order to show you the menu, so I can go. I can actually go look at that. Um, so if we go down, I'm sorry about the noise for the game. It is fairly loud. I've had some people complaining about that. But if we go look at the controls page, then you can see, if you look at my mouse over here, then down here in the corner, we have, I don't know if you can still see that. Yeah, down here in the corner, we have a toggle menu, toggle music. So I know it's very small. I can actually switch that up on the OBS software, so that's a lot bigger. So if you are looking at the screen here, then right there is it's just saying that the M button is the toggle music button, but I wanted to put that on there so that people could get that right away, because I know a lot of people didn't really like the music. I thought it was funny, but I know that can be a turnoff for some users. So if I go and play the game, I can show you the other very recent update. Let me just go find a box. I'm actually going to turn the music off so you can hear me. But the most recent update is that when you're right here in the corner of the box, you don't overlap in a weird way with the boxes. I did the math better. So you can kind of see it right there. That's just 1 pixel. So it's not the biggest problem. So what I want is, if you can go up, you should be overlapping with the box slightly. So at any point that you're colliding. So there might be some tweaks that need to go with that, but as of right now, I'm pretty happy with how it looks. There's a lot less overlap. It was just changing one number, so that's why I didn't make it a big update that I was announcing or anything. The big update was earlier this week, so I want to get back to explaining that. So I'm going to switch this back over to the paint window, and we're going to talk about the big update. Now, when I say big update, it's more of a big concept update. In terms of the actual coding that was necessary to enact this update, there was very minimal lines of code necessary in order to create this update. But first off, I want to lay a background for what the neural network is doing in my game. Also, I'm going to leave down here in the corner the game running so that you can see if the salesman will find us. It's currently running on easy, so if the salesman finds us on easy, we'll up it to medium, and maybe we'll get an idea of how much faster the salesman is finding you and how much more intelligent he is in his decision making on each level of difficulty. Now, I don't know that he will find us in every single in the entire length of this stream, because there are problems. So if you aren't moving, it's harder for the salesman to find you, because the direct path may be blocked by a lot of obstacles. So what can happen is, if you're moving around, that can let him kind of shift out of the way of obstacles as you're moving around, but slowly get closer to you. And so it is actually it's something that I'm going to leave in because obviously you're not progressing if you're not moving around. So it's okay if the salesman isn't attacking you when you're not moving around because you're not gaining anything from it, other than the fact that you might be waiting for the kid to stop running. But I don't know. I'll leave it in for now. And it's not something I can necessarily fix without just making the AI better. So that's something. Oh, there we go. We got the AI right there. He will have to figure out how to get to us around those boxes, but we are going to see how that goes. So I'm going to lay down some groundwork for how the AI is actually working. So if you know anything about neural networks, this should come pretty easily. But essentially, it's all layered matrix multiplication. So what we're doing is we have a large set of inputs. So I'm going to do that with these parentheses. And so we have our inputs here. And we want to convert these inputs into a small number of outputs. So in this case, we have 4 possible outputs for the salesman. He can either go right, left, up, or down. And so those are our possible outputs. Now, in my case, for this game, all of those outputs can be won at once. Now, that would come about with a lack of actual movement, because if you're going right and left, they cancel out. Same goes for up and down. So if all of these were ones, there would be no movement. He would actually have an animation of him running, just because that's how the coding worked out. So you can see sometimes he'll be running in place, but oh, there he goes, and we're dead. So I'm going to switch that over to the medium level while I'm talking here. And let me just get it switched before I talk. So what I was saying is that you may see him running in place, and that is the reason. So I'm actually going to try and put myself behind a box or something. Okay, we'll go there. So we have all this input data. Now, this input data is coming from 2 different sources. There is the visual data and there's the compass data. So I've explained this before. The AI has, if you want to visualize his inputs in a 2-dimensional system, which is not actually how he's getting it. It's all a 1-dimensional array, as seen here. But if you want to see what he's actually getting, you can imagine that here's our AI right here, and we're putting a box around him, a very small box. So in this case, for all of the levels of difficulty, he is only seeing the pixels immediately around him. And so these pixels can be populated with numbers. Those numbers are representing different things. So if they are a 2, that means they're an obstacle. If they are a 1, that means that the player is on the screen. So is that close to the person, to the AI. And there's also this kind of circular map around him that we can go like this, 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 and this, and I believe, yes. So we're going to go like that, that, and that. So we have all these dots, and we also know what general direction the user is in. So I'm going to put a dot here. So you can imagine we have all this information right here, and all of the compass data is just 8 digits. One of them is a 1, and all the other ones are zeros. So that is the data that's coming in. So originally what I had was I would put the visual data, then the compass data. And to improve the AI's ability to predict movement, I also fed him the visual data and the compass data for the past 2 frames. So it's a very small amount of time for us because it's running at 60 frames a second. That means he's getting 3/60ths of a second. So we can reduce that to 1/20th of a second worth of information. But he's only getting 3 points from within that 1/20th. So it's a little more complicated. But what I was doing was I would feed in the visual data for the current frame, the compass data for the current frame, and then in the second third of the data, I would put in the visual data for the second frame and the compass data for the second frame, and so on for the third frame. I decided that there was something I could add to this formula. So I was explaining neural networks. Essentially, what's happening is we have a couple extra layers in here. So I'm just going to draw lines for convenience sake. These layers, in my case, are all the same length. So they are just vectors of their own that are sort of mitigators for decision making. So they are, in this case, longer than the output. I find that to be more beneficial because if we want there to be more complex analysis of the data than the actual output. Now, there may be some cases where you're getting less data than you are spitting out outputs, but I'm not sure how the performance would be in that case. But what we're doing is there is a system of weights, and these weights are matrices. So these matrices are essentially drawing lines from each point in the input of the layer to every single point in the output of the layer. This is only efficient on a small scale. If you have a large scale, it does slow down the program substantially, and there are more efficient ways to do this, whether it be evolutionarily removing connections and keeping the amount of weights between layers relatively small. But in this case, I do have the processing power from within the game to completely connect every single point of the input layer to every single point of the output layer. So these weights are a large matrix that has the width of the input and the height of the output. So what that does is it converts a large amount of data into a slightly smaller amount of middle data. And this data is converted several times with more weights and more weights. And in the end, it comes out to 4 answers. Now, these 4 answers are converted into probabilities via a sigmoid function. What that means is it's actually, I believe, 1 minus 1 over e to the x. That is the sigmoid function. Correct me if I'm wrong. That is just off the top of my head. But what this does is it creates a probability based off of how big or small your number is. So if you imagine we put a big number in here, like 1,000,000, e to the 1,000,000 would be an extremely large number, but 1 divided by 1,000,000, or e to the 1,000,000 is a very small number, so 1 minus a very small number is very close to 1. So if it's very close to 1, then it's a high probability. If we have the opposite case, if we put a very negative number here, then we get a very large number, and we get a very large number in general. So we get a very negative number, or we can have something closer to 0 in that case. So what we're doing here is if the value of this output is greater than 0.5, I just round it up to a 1. And in the else case, I just say it's 0. And all that does is it allows the AI to analyze data and pick out a decision of these 4 possible outputs. So that's all the stuff that's been running in the game already. Now, what I added in this update is a middle step at the beginning of the data. So I'm going to clear this out just so I can zoom in on that. So we are going to be layering this out. So you can imagine that originally I had the visual data. I'm just going to say V, and then I had this smaller compass data, and then we had what was this? V0, C0, V1, C1, V2, C2, and you can see I got a little lazy at the end. So this was a fairly reasonable setup. It was pretty convenient because I could just keep chopping off the end of the array and putting the old array at the end of the new data, and it would just keep updating like that. But what I found was that I was thinking just in general about how the human brain analyzes things. And I was thinking the main thought that I was having was that if one sensory input is not giving valid data, say someone becomes blind, that would be an example, then what we find is that all of the other senses are amplified to try to mitigate the fact that there is less sensory information coming from the eyes. So the hearing, the smell, the touch would all be amplified because the brain is able to focus on those sensory inputs in order to get the correct answer since it doesn't have the visual data. So what I was thinking was that in the simple case, the AI is not necessarily sophisticated enough in order to analyze the visual data, at least at first. So I thought maybe I should give it the chance to, in the beginning, just weight the data itself before it even enters the neural network. So this would be, in this case, a way to sort of wash out the data that isn't important because it's not able to analyze that data. So what I had to change was I had to change the structure of this. So what I did was I created one large set of the visual data. So this is 0, 1, and 2. And then I have one large thing of the compass data. So this is 0, 1, and 2. So what this means is that all the visual data is in one place in the array, and the compass data is following that. And what I did was I just set up one little weight that is multiplied by all of the visual data and one little weight that is multiplied by all of the compass data. Now these are initialized as 1 because in the beginning I don't want it to be automatically favoring either of the two sets of sensory input, but I allow it to adjust these weights just like it adjusts any other weights that are connections between layers. And what that allows for is if it finds that the compass data is more important than the visual data, or vice versa, it can make that more important just to begin with. And it doesn't have to amplify each individual data point, which would be a lot more complex and a lot more difficult. It can just raise this value up, and it would make the visual data a lot more important for later on in the layers. So I did see a lot of good results from this. I found that the data, it allowed for the easy difficulty to be fairly quick in learning to follow the character because it was able to wash out the visual data, which is what we saw. We saw that the easy character did find my character fairly fast. Now, there is game mechanics that also make the easy difficulty easy. The salesman cannot attack the player from as far of a distance, so he has to be like right on top of the user. And also there are more candy bars on the map, so there are more hints available. But in the harder levels, like I've said in the past, it is harder for the AI to learn to get through all of its weights because there are more weights. So the learning process is significantly slower in the beginning. But with this setup, it is able to evolve. So perhaps it is able to learn to use the compass first, and then as it is learning more and more about the visual data and learns to, it can learn to avoid obstacles and then re-amplify the visual data so that it can get around boxes when necessary. Now, obviously, this is all theoretical. I can't necessarily impose this upon the AI because there are a lot of random things that must happen, but this is the idea that I'm going with. So what I've done is we have our normal layers here, and then we have our output over here. And all I've done is I've added these little weights in here so that they can adjust the data before it even enters the neural network. Now, I think this is probably nothing revolutionary. I would imagine there are a lot of neural networks doing this, but in terms of my personal research, this is the first time that I've done this. So I was pretty happy with the results because it was a very small change, but it did show very strong results with the AI. Now we are seeing that the medium level has not found our character here. We can try to maybe move around because of what I was talking about. If it's not very good at getting around obstacles, it will get stuck if I'm just waiting in one place. Because if you imagine like a sponge, there is usually a general path to get. Oh, there we go. So he was very strong on following me, at least in that direction. But then obviously he's not learned all the directions because when he got on top of me, he just went straight down. But if you imagine like a sponge and you're trying to put water through it, yeah, you can put water through it, but there's no real straight path to go through that, and that's what the boxes represent. Um, there are there are a small amount of lines that are just straight through the map because the boxes are just randomly placed. So if you're standing at any given point in the map, then the AI has to get lucky if it's just trying to take a straight trajectory towards you. So moving around does allow the AI to actually find you easier, assuming that it's just simply following you based off of whether you're to the right, go to the right, and things like that. So that's pretty much all I wanted to talk about. I don't want to drag on too much, but I was pretty happy with how this played out with this update here. So I am going to be switching over to the stock market update, but if you have any questions, you can leave those in the chat or in the comments later. And I will mention at this point, in case you are planning on signing off before the stock market update, I do have a poll up in the corner that you can vote for the stock in order to help fluctuate the votes in general, or fluctuate the values of the stock market. So I would be very happy if you would participate in that. It's pretty easy to do if you're on the YouTube app or if you are online, but it's there. So I will be transitioning over to the stock market. Okay, so I have my random. Oh, let me change the screen here. I have my random number generator, and we are going to be getting our market factor. First off, I will just reiterate the scoreboard here. So we have a pretty decent gap popping up between me and Megan and Even Steven. Even Steven leading the rest of the pack, which who are all over the beginning value. This is due to the fact that Even Steven is above average, meaning that the market in general has been doing fairly well. So me and Megan have been taking advantage of the more radical stock, I guess, and we will be seeing if that trend will continue. So I'm going to switch over to the value page. We can see that blue is still significantly larger than the others, but the others are starting to catch up. They're all above 100, which is the first that has happened in a decent bit, I believe. No, it's been a couple weeks actually. Ever since the big red spike, we have been fairly consistent. So we are going to pick a market factor. I'm going to hold this steady and hit. Oh my gosh. We have been so lucky with this, and I swear this is an honest randomizer. So I don't know what the problem is, but we have a 4, and so we're going to be updating what is going on with these. So first off, red received 0 votes, yellow received 50% of the votes. green received 0% of the votes, and if you are astute in the world of mathematics, you will know that blue received 50% of the vote. And I feel like we always kind of ruin the thunder for blue. Maybe I should go backwards next time. But we can see blue has now gone up to almost 300. So if blue is able to surpass that point, I think that would be a very substantial amount. Although benchmark numbers are arbitrary, assuming that you don't necessarily care about base. But in base 10, 300 is a pretty nice number. So we can hit new market here. We're going to zero out the market factor, and we'll go check the scoreboard. So you can see that I believe that's a similar margin. I think I had about 3,000 or 30,000 Jonos on Megan. Even Steven is creeping up to almost double his beginning, which is right along with the fact that I said that we have been seeing some interesting randomization. It's been significantly in the favor of the market increasing, and I guess you could cause that to inflation, but I don't think that is necessarily the case here. And so Mike took a nice spike for today because of the yellow increasing, as well as my sister due to her blue and yellow stock. Although red and green did decrease, they did not decrease by a significant amount. So we are going to go check out. So here are our values, 146.68. I'm going to update the historic data. So 146.168, and then we have a 126 and a 290. 126 and 290, and we're going to add a 12, my favorite number. And it's surprising that I've been doing this for 12 weeks. I doesn't really feel like I've been even streaming that long in general, but I guess we did have our anniversary over around week 1, so that means I'm actually getting pretty significantly far into my semester, which is a little scary, but we can update the graph here. Blue is doing its weird upward sinusoidal motion here. Green is continuing its somewhat downward trend, although it seems to be leveling out. Yellow is doing some sort of a spring thing, but seems to be trending upwards. I think that's due to my endorsement, if I have to say, and also Mike's, I guess. And red has seemingly touched a peak. We're not really sure how that's doing, but we will be seeing how that goes in the weeks to come. So I can see how we are going. Now, I do have a significant amount of red. I could sell out due to the fact that I see that it seems like it's kind of hitting a hump here. I did sell with blue here, and then I didn't really buy into too much more after that point. Maybe I should have bought here, but I don't think that I couldn't really see where it was going. At this point, it was going down, and I was kind of hoping it would go further down so that I could repurchase in like I did here at the that's week 3 when we had a value of 48. So I think I'm going to hold out where I am, but I am hoping to get some more guests on. So I was mentioning I wanted to have more than one guest a month. So if you are interested in coming on the stream, then you will be able to participate in the stock market here. But until then, keep an eye out on Facebook to see if I have any updates on people coming on the stream. If you've already been on the stream, then that's not necessarily a problem. We can maybe pick a more specific topic for you to talk about and then have a continuation of the conversation we had last time. So I'm going to be signing off here, but I want to thank you guys for watching. And also, I'm going to leave the link to my game in the description. I did in the last video on the game, but I figure I'll just keep, if I'm talking about the game, I'm going to leave the link to the game. It's completely free on itch.io. If you click the download button, it'll pop up with a window where you can offer to pay money, but you don't have to. There's a little link right above the box where you type in the dollar amount that says no thank you, continue to download, and then you can just download it. So it's fairly simple. It's everything's all in one folder, and you can just play the exe file, and you'll probably get some warnings because it's an exe file, and that's how old people spread viruses. But I can promise you, everything is working fine. So you don't have to worry about any data leaks or anything. It's a fairly simple game, so there aren't any problems with that. I don't think it's even it is accessing files, but all those files are in the folder, so uh, there's really nothing to worry about. So we've hit 30 minutes here. I'm going to be signing off, but thank you again to those who are watching. Don't forget to vote up in the corner. There is that little eye icon that pulls out the poll, and you can click for your stock. And I will be seeing you on, I believe, Saturday afternoon. So until then, goodbye.